So I found it interesting after doing a bunch of videos on deobfuscating the JavaScript files that the last one that I did was of a very interesting, twisty script that actually was what I was kind of thinking that things had the potential of doing the entire time. It actually went and downloaded a file that was not an executable file. It actually scrambled byte order around and made an executable file on your hard drive out of nonsense data stored on a website. Um, and then shortly after getting that email, uh, absolutely the well ran dry. There were no more JavaScript attachments came into my inbox for almost an entire month. And then suddenly in the past 48 hours, I've gotten 6 of them. Um, so I figured I would take a look at them just to see if there's any new generation differences on these ones or not. I suspect that because of the fact that they all came in at the same time, there's going to be a lot of similarity between them. And it's quite evident looking at these two, for example, these two, how it's just a template, obviously, with the only thing being changed is the random name and association that they belong to. And here, the only thing changing in its template is the name and the reference order. So, I've already gone ahead, and out of the 6, 5 of the files have the same JavaScript file name root, and 1 is different. So, yeah, they're pretty much going to be all likely the same. So a quick look between them. Let's start with the one that's all off on its own here. So clearly this is one giant string concatenated together and then processed. And the other ones here, this is a string. It's a string based on the fact that it's actually a character array. Yeah, it's an array of characters, which is another way of representing a string. So there'll be operations, operations performed on these. String array, string array, string array, and a string array. So yeah, very much all similar. What's the difference here? Well, the first one is obviously it's concatenation as opposed to an array. Just looking at the code, this is all backwards. So of course there'll be a reverse on this. For this one, again, it starts off with a semicolon and closing brace. So this one will be reversed. Next one, reversed as well. Next one, reverse. This one, not reversed. This one, straight up forward. Simply joined. And evaluated. And backwards. So I'm going to just quickly process all 6 of these files using methods I've done before, simply converting these files into an HTML thing that will dump the entire contents into a text area box. Turns out we don't actually need to put the head section in. And we're going to print these out as part of an inline script within the body. So we are going to make the body section. And then this becomes script. We replace this with a document write. But we also go one step further by making the text area box in order to make sure that we will preserve any HTML encoded characters, ampersands, greater than, less than signs, things that might not render correctly otherwise. And then we close it all out. Actually, the script gets closed first. Save this as an HTML document. And then we are able to open it. There's the code, which I can then copy and take over to a beautifier in order to format nicely and unescape any characters for us that need unescaping. Okay, so I'm going to now do the same process for the other files, and then this way we'll look to see if there are any similarities in the actual code itself. The first layer of obfuscation is obviously very much similar, but the actual code may be very different. Okay, so I finished processing all of the files and reduced them to the script code, and yes, they are quite similar indeed. In fact, the 4 last files have even identical variable names and identical code for very much a lot of it. The other 2 are a little bit different, but so far looking the same. Like one of the ones I did earlier, it's just simply all of the strings that we need just chopped up. And then looking through, again, just string after string after string. And then we get down to the real part here. And this part, by analogy to the code studied before, is where we will likely define the strings for the URLs to look at. So if the code turns out to be pretty much the same in all the cases, I should be able to get a list of all of the URLs impacted. But more importantly, I'll have to look further at the actual algorithms that the codes use to see if they do anything slightly different with the files. And let's take a look at the actual thing. Again, these part here, just from looking at the loops, the try, the returns here, the Wscript variables within here. By analogy, I'm going to assume that these are trying to determine which internet request object to create. And then we have our loop that will go through something. And we'll have to process this stuff to find out what functions are. Something like this, again, is the code we've seen before, looking for the size of the file to be within a certain range, or looking at some other property of the file. We have 2 functions. We recognize this one here. This is the check for the M and the Z, which is also present in the other ones. This is the bit shifting occurring. Yeah, it'll be interesting to find out if these files are in reverse order or not, or in regular order, or if there's something else done to modify them. But they all seem to have the same general structure, same set of tests, identical treatment for this part. So since we got a ready state right there, that means we've already requested the object. So this statement is the one to request the URLs. And again, looking back to the last video in the series from a month ago, the analogy is here. We have an array of URLs, counter, mod operation. So yeah, looking at these two, the code is actually identical for the part that is requesting the URLs. So I think the first step to do is to decode URLs. We'll just leave everything the way it is. Don't have to worry about cleaning it up, because we know from before, these are just simply wrapping obfuscation around each other. This is just simply a function that returns its own argument. Again, see a previous video for how I dealt with replacing those. But since I'm going to need to keep a lot of these variables in order to carry them all the way through trying to process this system, I'm just going to leave those as they are, and I'm going to look for, in these sections, we're going to output what these things are. Will this be dangerous? I don't think so. I don't know if I do it right. Okay, now as it is right now, if I ran this as an HTML page with script in it, it will actually download files and do work on them, and I don't want that. Actually, first let's just get rid of the comment code. That's probably going to be the same in the other document. So I'm going to assume that this code with the for loop is where we start with the whole tell it to start creating objects and moving things, whereas all of this should be, well, I guess we have a W script here as well. But at least this way I don't have to worry. I don't think it's going to end up running anything that's going to create malicious objects at this point. This is just string processing. This variable is the one with the URLs in it. So what we're going to do here is we're going to print out what it is into a text area box. Kind of make it stop here just to be on the safe side by throwing an extra comment wrap in there. And we'll just save that as an HTML file. Alright, so there we go. We have an array of URLs for that one. And I can pretty much go and do the same thing in the other code. So I'm going to do this for all of the files. I'm going to get a list of what the URLs are. And then that way we can check first to find out if there is any downloadable content, and just take a quick look at whatever does get downloaded. Despite the differences in the two files compared to the 4 that looked fairly identical, all 6 of the files use the exact same variable names for parts of these things here, so that made this easy. So yeah, I've gone through, and in every case there are 3 URLs provided. And I come up with a list of them here, because again, I will do the proper thing, and in each of these cases, if there is something still on each server, I will email to the, or send a contact mail of some sort to the site owner to inform them. Okay, so let's start with the first one. Yep, there is a file. Now, just to be on the safe side, I am going to just call this group A. And I'll just make it a text file. Now, if the other two have something on them, which they do, we know they're going to be the exact same file, because, so that's interesting. This could be the browser's attempt at rendering some data from it. Didn't do that for the other pages though. But clearly there is content at the destination, so look into that later. Okay, and that appears to be a file. So this one is actually gone, and so is that one. I'm just gonna go. The fact that it's trying to render as a document means that there's. Same with that one. We have a file here, which we will call group C. And someone replaced it for that. That's good of them. Okay. That one's been wiped out. There's something here. This is group D. And there is nothing there, so that's probably just been a deleted folder. Okay, we have a file in group E. There. There. And there. Okay, so a third of them that actually have files. Those other pages, browser actually rendering a page that it theoretically shouldn't render. Okay, so now with that done, let's take a look at the files that were they're all different sizes depending on their source, a couple of different sizes. So it's not the exact same identical file each time. That's pretty interesting as well. Let's take a look to see if any of them have a pattern to them. No pattern at the beginning. They are not executable files. So chances are they are completely byte rearranged and scrambled and perhaps even backwards. Something entirely different for the others. Okay, so that's where they start getting a little bit crazier. What is the pattern of these things typically, though? If I remember correctly, this will probably translate into length. AI's KTHTOP. I'm just going to replace these structures in each of the file with the term length, and that will also fix up some of the other places for a reference. Let's see. That 6 occurrences. Wonder if they were in the other files. They were. Again, that's a benefit of this time. This is actually lazy coding. This is a lazily encoded JavaScript thing. It's just to spam the same email accounts with so many variations of the exact same code. There's no variation to it. This is kind of boring, but at the same point, it's that part becomes length as well. How does it look in the other file? Yeah, uses the same one. So let's just stick with that and try this replacement. Yeah, that worked good. We need to find out down here, NWAQA. Okay, I recognize this as the length -4 and length -3 and length -2, length -1 kind of thing. So this whole system here is the this acts on result. Now let's look at this code because we can go backwards from here. We come through with an input string We probably modify some of the bytes in here as we go along, but we then definitely reverse the order of the bytes and then still perform operations on it. So this is definitely complex reversing. So that should be in every one of those files, the fact that it replaced 12 of them. So yeah, we're doing, in every single one of those cases, we're doing the exact same manipulation to them, provided they all have that reverse in them, which appear so far. Okay, so they do all reverse the code. And they all have the same byte rearranging. I have to look in there to see if the structures are any different. There's got to be a difference between them, given that the fact that there's two different major file sizes, but I'm not that interested in it at the moment. Yeah, at this point, I can effectively go through one of these scripts in detail the same way I did in a previous video, which I don't have the time to do that for these days right now. It just has to be an analogy to what I've seen before. Request. Finish reading. Write the output. This will be then reading the input back in again. And then reversing the input. Saving part. Yeah, that's the format for saving. And after finish saving, this will be the one for running it. The only thing left to do at this stage is we still don't know what these files are. The wise place to bet your mortgage money would be on this being another variation of Locky. But, you know, maybe Locky is outdated now. Maybe they've got some whole new system out there. The odds are probably not, because Locky is probably one of their best money-making schemes possible. Okay, so what I did was I went through each of the 6 file types in order, and since we were only able to download 4 files that can be processed, I got rid of the two groups that we can't use. For simplification, what I did here as well is I changed the URL array to be just the URL where I actually downloaded the file. So that part is the same in each one. And we're going to let this system, and the only thing I need to be concerned with is let it save but not run. Well, that's pretty easy to control. Working backwards, we know that the expand environment strings is a function of our system shell object, so I was able to at least assign that, which again confirms down here after we've processed the strings and confirmed that it's the right size. This function is where it gets saved to a file name, and then this tells it to run that path and file name. All I'm doing is blocking out the run part. So by doing this, I should have the ability to download 4 files. Okay, so let's see if I've made any errors in these files. To confirm where these are actually saving them. Maybe this is one of those ones that's saving something in a different folder location for once. This is part of the path. That's part of the path. That's part of the string name. It's file name. So where is that defined? Right there. And that is a mess. Oh, I'm looking at the wrong part. I need to just look at this part. Is a function that returns part in the middle. So AQ, and this will probably be the other. So AQ and FYI. So, yeah, no big change. Okay, now it just dawned on me again. I've been treating everything as JavaScript up until now and letting a browser open it and do all the stuff. So what I have to actually do is strip out the HTML parts and save these as a JS file and then have my Windows JScript engine process them. So quickly modify. I can hear my computer working hard. I can hear the CPU kick up on that one too. That one just had a surge, and there's the CPU working. Okay, so let's go looking for the temp files now. 1, 2, 3, 4. There we go. 4 executables transcribed from them. With different icons too, kind of neat. So I'm gonna have to copy of these. Actually, I'm gonna cut them out of my temp folder. A, C, D, and E in that order. Okay. We'll just look at the last analysis for this one. Locky. There we go. As expected. Ooh, not as many detected it. But it's also Locky. Ransomware. Locky as well. Slightly different name for some of the other things that time though. So it definitely must be a slightly newer variant of it. Especially for not getting detected by that many things. Ooh, we're going to reanalyze this one. See if it's detected any more than in the past few hours. Okay, I think we'll just call it at that. It doesn't need to be changing from this point. So, yeah, 19, slightly better than the previous scan a few hours earlier by somebody else. So, yeah, there we go. Four different files. Obviously, the code must be a little bit different within each of them. 4 different sources, even though they're the same download method, the same scrambling file method and everything, they're being detected slightly different ratios. So there's probably something a little different about each of those files that's... Well, again, we see that their file sizes are kind of different between them, so that's where it's going to be interesting when I do get the tools to be able to start looking at the binaries for these things, see how they compare. There we go. 4 out of 6. All in one day. All with the exact same algorithms and code. Even so nice as to have the exact same variable names. Kind of simplified that. So, enough experience from having seen so many of these examples before, and this looking pretty much exactly like the last major one last month, where it's pretty obvious the pattern at this point in time as to what part are the HTTP, which parts are the internet request objects, which parts are the system shell objects. They're going to save them in the temporary folder. They're going to do something with the strings. They're going to save them. They're going to run them. Pretty easy to pick those things out, even with that heavily obfuscated names and numbers. We can still see the patterns.